Hey robot makers, how you doing? Hope you're having a good day so far. So do you want to know how to make your own ultrasonic radar robot that can see with sound? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our keynote and we can make a start. So I'm going to do this slightly differently today. I normally record my shows all in one go, and it's like just over an hour long for probably the main content. And I recently had a chat with explainingcomputers.com and Chris Barnett, and he was saying this is probably harming my channel. So what I'm going to try and do is every 15 minutes I'm just going to pause, and we're going to basically have an edit point there. So Alex is going to start the stopwatch, and we're going to make sure that we get around about the 15-minute mark. We'll just stop for a part 2. I'm not going to stop this live stream. I'm going to cut it post-production. So I just wanted to sort of explain that as we go. So this is part 1. Let's get to it. So the session goals, we're going to be creating an ultrasonic radar robot using a rangefinder and a servo. It's a really simple build, really loads of fun. We're going to have a look at how ultrasonic radar works. We're going to have a look at how to build a radar display. I had quite a lot of fun doing this. Uses trigonometry. We're going to have a look at how that works. We're going to have a quick look at the 3D design and how I recycled some of my existing designs to make this one nice and simple to do. And we'll have a look at the electronics, how to wire this up. And of course, we're going to have a look at the code and have a live demo too. And at the end of the show, we'll have a live Q&A where we can have a chat and kind of hang out for a little bit. Okay, so let's get over to the ultrasonic radar and how this works. So ultrasonic rangefinder is mounted to a servo, and you can see on the diagram there, it's then rotating around that pivot point so that the ultrasonic rangefinder is sweeping around 180 degrees, and it can take a reading every single degree and store that reading, or it can it can build up a picture of what it can see in front of it. So what we're also going to do is output that to a radar display. So I've got some little displays. I love these tiny little displays. I'm going to mount one of these to the back of the robot in the full robot when we've finished the project. So currently I've just got this on my desk using a Pico Explora base from Pimoroni, just to sort of test out how this will work. So yes, later, the plan for the whole project, this is, like I said, part 1 of a few parts that are going to be coming. We're going to feed all these readings that we take in a sweep round. We're going to feed that into a machine learning algorithm, and we're going to build up some an artificial intelligent model, an MM model that can detect objects in front of it. So, for example, what I'm thinking is an object that's round like this has got a different profile than, say, a corner edge. So we're going to get it to train so it'll learn certain objects, and we can put in lots of different things, classify them, tag them, and we can build it up. And then we can run the neural network model on MicroPython device on a Pico, which is crazy. So we're going to try and do that. That's what we're going to do in the fullness of time. But today it's about how do we just make the mechanical rangefinder sweep round and take some readings. So there's a slightly different view of it. You can see there there's a servo horn just mounted on the back there that pokes through, and I've got one part I made earlier. This was the sort of first prototype, even got the blue tack on it still, and the servo would sort of fit into there, and the other part would sit on top. The servo holder would sit on top, and then the rangefinder would just push into that. So that's how it physically works. And you can see there it's made up of quite a few different parts, and we'll have a look at those slightly later on in the show. So the radar display, let's have a look and see how this actually works, shall we? So it's all about triangles. We're going to be using a SOHCAHTOA, if you remember that from high school, to work out some angles and some lengths of things. So what we're shooting for is we want the traditional kind of radar display. So we want it to sweep round 180 degree arc, ideally in green on a black background with a bit of a fade as it sweeps round. We'll see how we can achieve that. And any objects that are placed in front of the rangefinder will display on the scan proportionate to the length of the sweep. So we can factor that in. So the display will be housed on the back of the robot. So currently as it stands at the moment, I've not built that part. The display and the robot are slightly separate, but we will get that in the fullness of time. I've chosen to use PicoGraphics, which is a really great graphics library, particularly for drawing vector graphics, and this has been invented by Pimoroni. Now, there are some native graphics functionality within MicroPython. There is a frame buffer, library that you can use, and that has things like the line drawing thing, which we're going to use here. But I'm using PicoGraphics, which means I've used the Pimroni MicroPython. So if you're using Thonny, you can actually choose to install that. If you just hit the boot select button when you're powering up your Pico, you can then select to install Pimroni MicroPython. So PicoGraphics has this line primitive, and the way that it works is it takes 4 different integers. It takes an x1, a y1, an x2, and a y2. That should say at the bottom there it says y1, should say y2. And then it draws a line between those 2 points. So the x1, y1 is the sort of start point in the line. That can be anywhere on the actual display. It doesn't have to be top left. It can be anywhere. The line algorithm will figure out how to draw that. But you do need to have those. So if you remember on your computer graphics, X is the sort of across, Y is the down. So we need a start and end position. So the display itself, I'm using these really nice 240 by 240 color displays. They use this ST7789V display driver, and that's actually built into the Pico Explora base unit. So really nice and easy to sort of use this without having to do much configuration. Like I said, it's got 240 by 240 pixels. It's square. It's got this in-plane switching display, IPS display, which means it's got a really nice viewing angle. So depending where you are, you can sort of see it from any angle. It uses the SPI bus as well, just to make it really easy to plug in from a wiring perspective. You just need 4 wires. And I'm also looking to put the breakout version of this on the back of the robot. So Pimroni do a breakout version, which means it's just got it's got 5 header pins. I think one of them's probably not used, or it might be the brightness. I think you can adjust on one of the pins, the CS pin. So yeah, that's what we're going to be using in the sort of long term. So if you're going to build along this, I'll put a full bill of materials on the site when I've finished building this. That's what we're shooting for. So how do we draw the sweep? So I was thinking about this. How do you draw an arc, in fact, on computer graphics? Well, what we need to do is we know the length of the line that we're going to draw, because we can start out and just say if our display is like 240 wide, let's split that in half. So it's what's that, 120? Let's give ourselves a little bit of breathing room. So the line will be 100 pixels long. So we know the length of the line. We know the angle of the line that we're going to draw as well. So we know those 2 things already. So we want to draw this series of lines, one for each of the 180-degree sweeps that we're going to make. So to draw the line, we need to solve these triangles and find the x1 and y1 positions, because we always know the x2 and y2 positions. I've got that spelling mistake down there as well, because that's in the middle of the bottom of the display, so it can sweep round completely. So we can use this line once we've found and we've solved our triangle. We can then use it to do the x1, y1, x2, y2, and then draw the line. And we can choose what colour we want the line to be, and so on. So drawing the sweep, this is what we need to figure out. We need to solve the triangle to figure out the positions of x1, y1. We know what x2, y2 is. Like I said, it's the middle bottom of the screen. So y2 is the bottom of the screen. So whatever the height is, it's the very bottom of that. So 240 or 239 if we're starting at 0, which display usually do. And the middle of the display is whatever the width of the display is, and we can actually grab that using PicoGraphics. You can just say get bounds to get the actual width of the display, just in case you're using a different size display. And then you can basically just say slice that in 2, divide by 2 to get the x2 position. And then we know the length of side C on our triangle there, or that angle there. We know side C, that's the 100 pixels. And really, when we're doing algebra, we just need to know it's 100 something. We don't really care it's pixels at that point. We know the angle A, because angle A is the angle we're currently sweeping at. We'll have a little function that goes through and counts 180 degrees and passes that through. And then we also know that C is always going to be a right angle. It's always going to be 90 degrees. So if we know A and we know C, we can work out what B is, because it's simply 180 minus A plus C. And that'll give us our B angle. And because we know that, we can then work out the rest of the length of the sides, because we know the angles and we know the length of one side. So we can use a bit of trigonometry to do that, and we'll do that on the next screen. So we know the length of side C of the triangle, we know angle A and angle C. We need to find the length of the side A, and the lowercase a there, to get the y1, so it's the height from the bottom of the screen up, and also the length of the side B, or it's actually the middle of the screen, minus B, lowercase b. Once we know those 2 things, we can then draw our line. Cool. I had to figure this out all by myself. So this is an AAS triangle, an angle side triangle, and if we know what kind of triangle we're trying to solve, we know which kind of algorithm to use to solve that. So like I said, to find angle B, which is in orange there, we simply say 180, which is the, if you remember from trigonometry, 180 is how many degrees you have in a triangle. And if we know A and C added together, minus 180 will get whatever B is. So that's a nice easy one there. And then to work out sides A and sides B, we just need to do a little bit of trigonometry using sin. So if you remember, you have like tan, cosine and sin, and we're basically just going to use sin to work out the length there. So the actual MicroPython code is this piece down here. So we need to actually cast it, as they say, into an integer. So in case we divide stuff, it ends up being like a floating point number. That's not really good for our display. We want pixels, so we want an absolute number. So casting it as an integer will make sure it is a whole number. And then we say c times by sin, and then the sin function actually works in radians, so that's actually 360 degrees. We need to get rid of that and just make it into 180, so we can just use the radians function to do that bit for us. So that's what all those brackets for there. Capital A is just the main angle that we're going to pass in. We want to find out what A and B are. We divide that by sin and then radians C, which is the other angle, which we know is 90 degrees, and then we'll get the length of A, which means we can figure out what our our Y1 position is, and if we figure out B, we can figure out what our X1 position is, and then draw our line. So that's what we're going to do. So how are we doing on time there? I've got another couple of minutes yet, haven't we? So let's have a dive into the 3D design. So the chassis is actually the Explora base. So I've got my old Explora robot here. This is one I built earlier, and this chassis that I've got here is a really good I designed it to be like this. It's a really good use case for any kind of robot you want to build. All you need to specify is where the holes are. So this particular one was for a Pico Explora hat even, because it's got a Raspberry Pi Zero underneath, and this one had the rangefinder sort of sandwiched between two things, and there was even a space there for a Raspberry Pi camera as well if you wanted to use that on this particular one. And this one had a little rangefinder. Well, it's an infrared line sensor unit on that particular one. This is an old model, and what I've done is I've basically just taken the measurements of this and I've just repurposed them for my new robot. And it's really simple to put together. I'll show you the blueprint in a second on the next screen, so you can create these yourself. And it's 3mm thick, and that seems to be a really good thickness. It doesn't bend, it's really solid, and it's really quick to print. Doesn't take very long at all. So it's solid, doesn't bend. Very easy to attach your motors to as well. So I'll show you that in a second. Underneath I've got some N20 motors, and I've got a little motor holder that just screws into place with 2 M3 screws and nuts. And we'll have a look at some captive nuts as well on one of the diagrams in a second. So this is the blueprint. You can see there it's 90mm by 70mm. There's a rectangle in the middle, and then we've kind of got like a front and a back piece on there as well. And then there's little tabs, if you like, for where the wheels go. It just gives the wheels a bit of clearance away from the main body, and they can sort of sit over the top of that. And it works for lots of different types of wheels. So there, if you look there, we've got a 5mm distance between that side and that side. It's 8.5 sort of tall and 16 wide in the middle, and then they just anchor to the very edges of that rectangle. So there are all the main measurements that you need to have there. So the servo holder, this is the piece. It's a sort of shorter version of this. That this one was like the full height of a servo, so I could just test that out on the desk. This one for the robot is slightly slimmer, and the servo pokes through the bottom of the chassis as well, so there's a little space for that. And it's held in place by 3 M3 captive nuts. There's one sort of hidden inside that you can't see on the model, but there's one there as well. And the way that these captive nuts work, they're a really good way of securing 3D printed parts together. So you just have a little nut piece that goes in, so you've got a little hexagonal nut shape, and you've got the M3 bolt that goes through the nut, and sort of two squished together. You don't have to over tighten them, they're pretty secure, and it really holds everything in place. So I really like including these in my designs. It's a really nice way of making things easy to print because they're separate parts. So yeah, the servo screws in from underneath. So I'm using it's a Tower Pro MG92B, which is this one here. It's almost the exact same dimensions as an SG90, the sort of cheaper ones. I've got a sort of slightly better quality one just because I wanted this robot to be as accurate as possible, and I found on some of these cheaper SG90s they can be a little bit flaky, so I thought for this particular robot I wanted a bit more accuracy, so I paid a little bit more for one of these. I've got a whole pack of them. So works with the MG90s, SG90s, the DS929MGs, which I've used in other robots in the past, as well as these Tower Pro MG92Bs. Okay, so next is the rangefinder holder. This attaches the servo horn to the servo horn attaches the rangefinder holder to the body and gives it that pivot point in the very middle where we need it to be. What we do need to make sure though that is before we actually put that little screw in place, so you'll get a little bag like this when you buy your servos, and there's a tiny little screw in there that you screw into the sort of spindle of the servo, and that just before you do that you just need to make sure that your servo is centered and your rangefinder thing is pointing forward. Now I have got my desk of bits here. Just unplug that. You can see the time there as well, which is good. What I've got in my desk here is just a little servo, what do you call this? A servo consistency tester or something, and it basically just has a little knob on there, and you can plug in a number of different servos, like I think 3 of them. You apply some power on there and it'll just set the servo, and you can just dial this, so you don't have to have anything else connected to it. You can just use this to sort of set it. So there's a little button on board as well. If you click that, you can basically set it between 1 of 3 different settings. So I use that to just make sure it's completely centered before I screw everything into place. Okay. Yeah, I'm just going to run 2 minutes over just to get this bit done, Alex, but thank you for that. So yes, the ultrasonic rangefinder simply just pushes into place on the back of the rangefinder holder. You don't need any glue or screws, and then you can connect up just using one of these DuPont cables. I've got a pack of these, and depending what you've got on the other end, you might want the male to male, male to female, female to female, whatever works really, and you just need 4 of these. So you've got ground, voltage, trigger and echo. And if you've not joined our Discord server, you're missing out massively. You want to go over to kevsrobots.com/discord. It's completely free to join, and you can have the deeper conversation with us, and I'll be spending a bit more time hanging out with people through the week, and if anybody has any problems they can ask questions there as well. You can also follow me on social media. So I'm on Instagram as Kevin McAleer. I'm on Twitter. I'm still on Twitter as KevsMac. I'm going to see how Twitter goes. I'm also on Mastodon as well. I think I'm just on Kevin McAleer at Mastodon Social, I think, on that one. I'll have a look, but I've not really posted very much on there at the moment. It seems to be quite buggy at the moment, as in it crashes quite a bit. I am also on TikTok, so I've not put my TikTok thing on this particular thing, but you can see down here on the side where I am, just below me, Kevin McAleer 6 on TikTok. I did a video on TikTok. It was this robot that we've just been looking at today, the Ultrasonic Range Finder one. Alex has just put a link in the chat there. And let me bring that one up actually, just so you can see it. I'll include this in the video description as well actually. But you can check out this particular one. It's had like over 46,000 views, I believe, at the moment. Is that what it's on? Yep. So it's doing ridiculously well for a robot video. But I think we've figured out how to do these and make these popular. Just good for a bit of fun and growing the channel. Okay, and if you want to help the channel out, which a growing number of people are doing, which really helps support the channel, you can do a super thanks. So next to the join button, hint on the YouTube play, there's a super thanks button. If you're watching live now in chat, you can, watching on the live stream that is, you can hit the super chat button, super thanks button, super chat button if you're watching on this live on the live stream, and again that helps out the channel, and you get a special call out as well for that. And you can go over to kevsrobots.com/coffee if you want to buy me a coffee as well, which quite a few people have done recently, so thank you very much for that. You'll get a shout out in a second. And if you want to join the membership program, which a growing number of people have as well, you can also join the YouTube membership as well. Okay, so let me just go to the next piece, which is our supporters. Yes, I've got a special button I press for that. So here are our supporters. These are all people who have been very generous in supporting the channel by buying me a coffee. So you can see we've got Frank there, we've got Dana Huff, we've got Grumpy Scrambler, we've got David, we've got Matt Hungerford, we've got Flavia of Dev, and we've got Patrick. Then we've got a number of members as well on the Buy Me a Coffee membership program. So we've got Chemi. I think he's on a gold program at the moment. So that's Shemi. I keep saying it wrong. Thank you, Alex. Shemi. We've got Steve, and we have Thomas as well, one of our longest subscribers and supporters. And then we have a growing number of YouTube members. So Michael, I think you joined recently. We've got Bill, we have Jose, we have Jeff, we have Johan, and we have Jean-Paul and Tom. Cool. So if you want to get your names on here, you need to head over to kevsrobots.com/credits, and you can do that. Okay. And that's it for the show today on the replay version of the show. So if you're watching this on replay, this is the point in the video where I'll say thank you so much for watching. I hope you've enjoyed this part of the video and the other 3 parts as well, and I shall see you next time.